In 2022, for the first time, scientists captured an image of the shadow of a black hole, proving that these long hypothesized objects actually exist. In this course, we'll explore what these incredible objects are, how we know they exist, and what might lie at their core. The word black hole might bring to mind a dark, empty region in space, devoid of any light. But in fact, a black hole is one of the densest objects in the universe. A black hole is a region in space from within which nothing can escape. But it's not empty. A black hole is a concentration of matter, often stellar remnants, packed into an extremely small space. The boundaries of this region from which nothing can escape is known as the event horizon. Once something crosses the event horizon, it can never return to the outside universe. Not even light can escape a black hole. That's why black holes are called black. The gravity near the edge of a black hole is so strong that if you were to venture too close, you would be pulled across the event horizon and beyond, forever trapped within the black hole. To understand black holes, let's first look at something familiar: the Sun. Our closest star is around 400 times larger than Earth and weighs 333,000 times more than our planet. Yet when we observe it, the Sun appears smaller than Earth. That's because the Sun is incredibly far away, about 150 million kilometers from Earth. How big something appears in the sky depends on two things: its actual size and how far away it is. Objects far away appear smaller and closer objects appear larger. The apparent size of an object in the sky is known as its angular diameter. To measure it, astronomers use arc seconds. An arc second is 1/3600th of a degree. The angular diameter of the Sun is around 32 arc seconds. You can use this unit to measure other objects in the sky as well. For example, the full moon has an angular diameter of around 2 arc minutes, which is 60 arc seconds. The angular diameter of a black hole is always the same, regardless of how far away it is. That's because the gravity of the black hole prevents it from getting any bigger. Let's take a moment to appreciate how bizarre this is. The Sun is huge. Its radius is 696,000 kilometers. Yet from Earth, it appears the same size as a tiny black hole. That's because the black hole has infinite density. That means it has squeezed itself to become unimaginably small. And the Sun isn't particularly big. Compared with some stars, it's a red dwarf. If we could shrink the Sun until it had the same angular diameter as a black hole, its radius would be only 8 millimeters across. To put that in perspective, a soccer ball would have a radius of around 22 centimeters. Black holes come in a variety of sizes. The smallest ones are called stellar black holes. They form when massive stars collapse at the end of their lives. Stellar black holes typically have masses ranging from about 3 to 100 times the mass of the Sun. At the other extreme are supermassive black holes. These giants have millions or even billions of times the mass of the Sun. Supermassive black holes are found at the centers of most galaxies, including the Milky Way. Black holes can also have electric charges. While most of them are electrically neutral, some may possess significant charges due to processes such as accretion. Accretion refers to the gradual accumulation of matter onto the black hole. As matter falls into the black hole, it forms an accretion disk. This disk of swirling matter heats up to millions of degrees and emits bright light that can be detected by telescopes on Earth. The charged particles in the accretion disk generate magnetic fields that extend far out into space. These magnetic fields can funnel charged particles toward the black hole, accelerating them to near the speed of light. As these charged particles approach the black hole, they emit radiation that can be observed by telescopes on Earth. Charged black holes with electric charges also emit electromagnetic radiation, including radio waves, X-rays, and gamma rays. These emissions arise from the interaction between the black hole's magnetic field and the charged particles surrounding it. As mentioned earlier, black holes can also possess angular momentum, which is a measure of an object's rotational motion. When matter collapses to form a black hole, it carries with it any initial angular momentum it possessed. This angular momentum is then conserved during the formation of the black hole. As a result, most black holes rotate. The rotation of a black hole can significantly affect its behavior and properties. It influences the shape of the accretion disk and the dynamics of matter as it falls into the black hole. The charged particles in the accretion disk interact with the black hole's magnetic field, which is influenced by its rotation. This interaction leads to the emission of radiation, including radio waves, X-rays, and gamma rays. Additionally, the rotation of a black hole affects the gravitational lensing effects it produces. Gravitational lensing occurs when the gravity of a massive object, such as a black hole, distorts and magnifies the light of background objects. The rotating black hole creates a rotating gravitational field that can magnify and distort the images of background sources in a unique way compared to a non-rotating black hole. Despite their immense gravity, black holes don't suck in matter. To understand why, let's take a step back and think about how planets orbit stars. Planets don't fall into their stars despite the star's gravity. That's because their forward motion keeps them moving around the star in a circle. You can try this yourself. If you swing a bucket of water around in a circle, the water stays in the bucket even though Earth's gravity is pulling it down. The faster you swing the bucket, the more the water sloshes up the side of the bucket. The force of gravity pulls everything towards the center of the Earth. To overcome this, you need to apply an equal and opposite force. This is why astronauts experience weightlessness in orbit. They're falling around Earth, but their speed keeps them from crashing into the planet. Black holes have intense gravity, but that doesn't mean they suck in matter. From far enough away, black holes are just like other objects with gravity. You can orbit a black hole just as you can orbit a star. What makes black holes so strange is that they are incredibly dense. All of their mass is packed into a very small space, which means their gravity is very strong. If you get too close to a black hole, their gravity will pull you in and cross the event horizon. Then no part of you will ever escape the black hole. But if you stay far enough away from the black hole, you'll be fine. Now let's talk about what might lie at the core of a black hole. At the edge of a black hole, space-time becomes highly distorted. As you approach the event horizon, time slows down relative to an observer far away from the black hole. This means that if you were to cross the event horizon, time would eventually stop for you. Any light emitted from beyond the event horizon would take an infinite amount of time to reach an outside observer, meaning nothing could ever escape from inside a black hole. So once something crosses the event horizon, we can never know what happens to it. Because of this, there are many theories about what might happen at the center of a black hole, but we'll never be able to test them. One theory is that matter gets crushed to an infinitely small point, called a singularity. Others believe that matter is destroyed at the event horizon, and nothing can escape. There may be additional dimensions at the center of a black hole that we can't see. One popular theory is that there are multiple universes and that the center of a black hole connects to another universe. These are just theories, though. We don't really know what happens at the center of a black hole. To learn more about black holes, check out the courses on our platform. In addition to watching videos, you can also interact with the content through quizzes and exercises. You can learn at your own pace and even earn badges for your progress. We offer a range of membership options so you can choose the one that suits you best. Thanks for watching.